will discuss session 1 and session 2 both questions. So some people are saying that question was very tough, some people are saying it's not tough. So if you consider all population, then you can say that yeah, question was moderate, okay, which was good at all, okay. So you can't say that question was too much up top, okay, and even you can't say the question was so easy, okay. Yeah, question was moderate, okay. So that's maintained by the concepts, okay. So basically I had discussed so many questions. Who had gone through all the questions, definitely, okay, they can solve most of the questions to score, okay, good. But okay, it's very difficult to go through all questions, okay. Most of the people don't want to go through the questions, okay. They don't like to do questions. They just try to avoid the questions, okay. So I don't want to comment on all this, but okay, from my point of view, I have done so many things, okay. I have discussed so many concepts, so many questions. I have discussed thousands of questions over there, okay. So which covers almost whole syllabus, whole things, okay, which covers all the portions, okay, uh, up to the mark, okay. You can solve all questions if you have gone through the questions. So who had gone through the questions, definitely they got benefited and they are going to do better, okay. But okay, you know, most of the population don't want to go through that, okay. They don't want to put, okay, efforts there. So I don't want to comment on that, okay. So basically I'm going to discuss all the concept which can, okay, help you to conversations, okay. So here, if there is, suppose what we are doing, one concept is here, there is a string here and it is connected through it, okay. It is connected through it, okay. And you here you attach some mass, okay. Suppose here you attach some mass, so that is capital M, yeah, a small m, and this mass of this block is capital M. So the question will ask you tension in it, okay. Tension in it, okay. So how can you find out tension? So whenever question comes in front of you, only try to think first two things that is very very important. First thing is balancing of force, okay. And if the object is in equilibrium, then net torque is zero, okay. Net torque is zero, while net force is zero, net torque is zero, okay. So when there is in equilibrium, okay. If there is no equilibrium, so there is tau net. If there is no equilibrium, then there is tau net, okay. From where question came in the examination, okay, over there. So if there is net force, net torque is not zero, non-zero, so then you need to do tau equals to I into alpha, okay. Always after this relation you will solve all the questions easily. Most of the 95% of the questions you can solve from this concept, that tau equals to I alpha. So here is what. So first I am discussing this, okay, for future point of view, that again, that if you have to balance your force, so simply the mass of this whole block is capital M, okay. And length of this, okay, suppose I am taking up some values over here. Suppose this length is 100 centimeter and this is 25 centimeter. So there will be a center of mass of this block, this is mg. Mg will be in downward direction, so this is m of g, okay, in downward direction. And this is small m into g in downward direction. So what is total force? T1 plus T2 equals to capital Mg plus of small m into g. This is equation number 1. This is equation number 1, okay. You did balancing of force over here, okay. Next thing you need to do is that torque. Torque, you can take torque about any point is 0. You can consider torque about any point is 0. You can consider either this point, okay, either this point, or either you consider this point. Suppose I am calculating the net torque about this center of mass. This is what C1, center of mass. Net torque about center of mass is 0. So there is no need to take, okay, torque because of mg, because of this whole mass capital M, because the torque about this point will be 0. So torque about this point, okay. If you see this force, so because of this force, torque will be clockwise, okay. Because of this, okay, torque, okay, torque will be anti-clockwise. This will be torque will be anti-clockwise, and because of this, if you see this, torque will be anti-clockwise. Yes or no? Because we are calculating torque about this center of mass. If you want to calculate torque about this is what, okay, and this force is what, mg, downward direction. Or what is the distance? This is 25 centimeter, this is 100 centimeter, so this will be again 25 centimeter. So mg into 25 centimeter, you need to take care of unit as well, okay. So mg into 25 centimeters. So this torque, because of this is clockwise, okay. And torque because of T2, so about center of mass, so T2 into this whole distance, T2 into of 50. So this is what anti-clockwise, this is what anti-clockwise, and torque because of this is what, okay, T1 into distance from the center of mass, okay, T1 into again 50. Okay, considering the unit, you have to need to convert centimeter into meter, or you can check out that is cancelable or not. Okay, so this is again what, clockwise. Okay, so you can take all the clockwise positive, all the anti-clockwise negative, or as it is. Okay, you reverse the direction as well, and net torque is 0. So from this concept, okay, when you net torque, you do net torque equals to 0, so you will get all the relation from it. This is one type of questions. Okay, comes in front of us. Next questions, what comes in front of us, that again the same situations happens, but what we do, this is to a string and block is connected through it. Okay, suppose the mass of this block is m and length of this block is l, and this is a string 1, so tension in this T1, and suppose tension in T2. So what question will ask you that, okay, suppose if we cut, okay, if we cut, okay, and suppose this point is connected through the end point, okay, end point, okay. So if we cut this string, so what will be the, okay, alpha of this, okay, what will be the angular acceleration, what will be the angular acceleration. So if you cut this acceleration, what will be angular acceleration, what is tension in it, the question can ask you also tension in it. Okay, then what to do, what I said, okay, always do torque equals to I into alpha, always, okay, so torque equals to what, I into alpha. Now here, if you see there is two unknown, one is tau and tension T, and one is alpha. Known is M and L only. Okay. So in such situation, what to do? You need to consider tau equals to, you need to apply tau equals to I into about 2 points. One is about center of mass and one about any other point you can take it. Okay. So suppose here center of mass. So this, because of the center of mass, this is downward, that is mg. So if I want to calculate torque about this point, okay, torque about this point, okay. The torque about this point, because of mg will be 0, and what, because of this tension, so T, and this is what, L by 2, so T into L by 2. So torque because of this is torque T into L by 2. So torque will come because this is, okay, we are cutting this string, so at that instant we want to calculate the here alpha over here, so T, okay, T into of this distance, okay, T into of this distance, L by 2, this torque is I into alpha. So if you need to calculate moment of inertia about this point, if you calculate moment of inertia about this point, what will be this, ml square by 12. Okay, so this is what, ml square by 12 into ml square by, this is 12, okay, into alpha. This is one equation. Okay, you can't calculate right now alpha because T is unknown here. Okay, again you need to calculate torque about this point. So if you calculate torque about this point, the torque because of tension will be 0, but torque will come because of this mg. So what will be again, mg into L by 2, mg into L by 2. Now the moment of inertia you need to consider about this point. Okay, I will be over here what, ml square by 3. So this is what, ml square by 3 into of ml square by 3 into of alpha. So this is equation number 2. So using equation 1 and 2 you can solve this question. This is very important questions, okay, coming this section. So okay, that's, you can do it. So all questions are easy. Just if you had gone through my series, I have made so many series over there, so definitely it will help you out over there. But as I say, most population don't want to go through the series because it's boring. It's boring and tough. It's boring and tough. Another is what? Suppose there is any metal over here, aluminum, another is copper, aluminum and copper, and it is free. Not, we are not putting any external from this side and this side as well. Okay, so question will ask you total L or delta L of total expansion. So we no need to think anything else. Just say delta of L is because of delta L because of aluminum plus delta L because of copper. And what is delta L? L alpha of aluminum and delta of T because temperature across, okay, temperature is maintaining same. Temperature is changing same. Suppose temperature is changing 20 degrees Celsius to 70 degrees Celsius. So what is delta T here? 50 degrees Celsius. Okay. L alpha of aluminum into delta T plus of, okay, this is L of aluminum. This length may be identical variable, so I am putting here variable. Okay, and plus of L of copper into alpha of copper. This value will be given in the question. So alpha of aluminum, alpha of copper, and delta T will be similar according to category 1. This is easily you can solve it. Another question can play with you. That question will not give you this temperature, whole temperature. The question will say that this temperature is 20 degrees Celsius, this temperature is 70 degrees Celsius, and then find out total del L, del net of L. In such situation, what do you need to do? First, you have to calculate the temperature of junction. Temperature of junction. So how to calculate temperature of junction? So you can use, okay, suppose length is different, and okay, alpha is obviously different. If length is different, so in the situation result is different. Okay, I'm giving the result assuming that length are similar. So if lengths are similar, so this result from alpha 1, okay, t1 plus alpha 2 t2. Alpha 1 is for this one, alpha 1, alpha 2 is for this one, this alpha 2. This is alpha 1, this is alpha 2. I'm considering this, and divided by alpha 1 plus of alpha 2. So from here, using this relation, you can find out the temperature of junction. This is temperature of this junction. So using this relation, you can find out temperature of this junction. Otherwise, you can also use the relation heat transfer. Q by T will be same because this is connected. This Q by T will be same. And what is this Q by T? Delta T divided by R. Delta T divided by R. Delta T is what? For this T minus this. For this 70 minus T. And what is R? You should remember this R is what? L by Ka. Okay. So in the situation also question can also play with you conductivity as well. Question can mix you the concept of conductivity as well. But here question is talking about thermal expansion, so you should know this relation over here. Suppose if L1 and L2 is different, so you need to calculate L1 temperature equilibrium separately, then you need to find out. So this is one question coming okay in front of you. So you should know this question. Another question is what? Okay, you should know how to calculate CV, CP. Okay, what's the difference between CP and CP? It's very important. I always say it's very okay understanding. There is very less question from kinetic KTZ. There was very less question from KTZ. But thermodynamics, okay, over here you need to take care the CP minus CP is R, okay. CP minus CP is R, and CP is what? F by 2 into R. CP is what? F by 2 into R. Question will give you this value and this value, and this. From here you can also say that CP equal to CV plus of R, okay. So if you know the value of CV, so if you add okay R to it, you will get CP. So always don't mix CP and CV. CP is different, CV is different. Okay, what is CP? CP is heat capacity. Okay, at okay constant pressure. CV is at constant volume. So CP we use for the calculation of heat. CV we use for the calculation of internal energy. So when we calculate internal energy, so delta U is what? NCV delta T. When we calculate heat Q, then we'll use NCP delta T. Both are different, don't mix this. Okay, gamma is always Cp by Cv. Gamma is what? Cp by Cv. From here you can solve all questions, okay. And always take care of in your brain that if you are giving heat, so it will come okay work plus of delta U. So you delta U can also calculate directly here. So this is what? NFR delta T by 2, or you can say NFR delta T divided by 2. NFR delta T divided by 2. NFR delta T, this result is very important, solves many questions directly. Heat will be given, so heat is given to the system, okay, then you need to take negative sign. If you are giving work is done on the system, then take negative sign. Always take care of sign as well, because many people do mistake over here. And if work is done by the system, then take it positive. Work done by the system, then take it positive. So this understanding again very important. So if you know this concept, you can solve so many okay concepts. Another question is coming from terminal velocities. Okay, this concept is very important. I have discussed so many questions. Okay, definitely it will benefit you. So the questions hard. If questions ask you about thermal, okay, questions ask you about what? If questions is coming for uh, what? Terminal velocity. So terminal velocity, in case of terminal velocity, see. So terminal velocity is what? Always remember this is Vt is what? 2 by 9 eta sigma minus rho r square into g. So here question is playing this time okay with the radius. So if you are giving the ratio of the radius, so basically terminal velocity comes directly proportional to r square directly. So you can say terminal velocity because of terminal velocity because of 2 is r1 by r2 of s square. The question is giving you the ratio of the radius. Okay, ratio of radius, you can find out the ratio of terminal velocity. So here, so again this is very important question. From fluid this question is coming. This is very important again. Yeah, now comes to the kinematics. Kinematics again very good and easy questions are coming. You can solve it if you know the basics. But for that, suppose if question had given you the force, okay, suppose question had given you the force is 20 I cap minus 20 j cap, and mass is what? 5 kg. So you need to find out for acceleration. Acceleration is what? Force divided by mass. So this will be, if you divide it simply, 4 I cap minus of 4 j cap. This is level 1. Another level 2, they can play with you like this. Okay, so they will give you this as a function of time. Suppose giving the t square, this is 20 t square. This is what? 4 t square. This is what? 4 t square. and so acceleration is 4t square minus of 4g. So acceleration what dv by dt. So you can say dv by dt is what 4t square I cap minus of 4j cap. Now you need to differentiate this. So dv is what 4t square of dt I cap and minus of dt of j cap. Okay, this is here 4 dt. Now you will integrate both sides. You will get the after integration you will get the velocity, and question will give the time. You can put the time. You will get the velocity at the time. This is again very famous and important concept. This one. Another question is coming from significant figure. So in significant figure, you should know addition and multiplication. That is very important. If question is asking you about addition, so if I am saying 4.02, 5.112, 5.4421. So add these numbers. When you are adding or subtracting, you have to see the after decimal list number of significant figure. List number of significant here is 2 here. So just your answer should be always okay containing list number of significant figure after decimal is only 2 in addition subtraction. But if you are suppose question asking you 1.11 and okay, into 1.212 multiplication, so if you are doing multiplication at a time you have to see whole number list level multiplication, list number of significant figure. This is 3 here. So from here you can solve this question. Another question is coming that resistance. Usually question comes in resistance in series and resistance in parallel, but this question is present with a spring constant K and K. So basically resistant, okay, and a resistance in series, okay, resistance in series. So what is R equivalent? R1 plus of R2 and parallel 1 by R equivalent is what? 1 by R1 plus of 1 by R2. But what question asking about error? Okay, error. So if question is asking error here, delta R of equivalence, you can say simply that delta of R1 plus of delta of R2 error. You can simply add error over here, but you cannot add error, okay, in parallel combination. So I am just explaining the final result because so which will help you. Okay, so if you differentiate it, so it will come like this: d of RQ divided by R equivalent square equals to minus will come everywhere, so you can cancel out minus everywhere. So this will be what? D of R1 divided by R1 square plus of D of R2 divided by R2 square. So basically D is nothing, that is delta. So I am writing here result. So basically we need delta of R divided by R equivalent into 100. This is error in measurement, final error in the measurement. Okay, so I take this one R equivalent right side, multiply right side and write in terms of delta of R. So I am writing over here. So this is what delta of R1 divided by R1 square plus delta of R2 divided by R2 square into of this is R equivalent here multiply by R equivalent. So basically you need to calculate R equivalent first and then solve this, put this relation. This time what they are doing, they are just replacing resistance by a spring. So there is no any difference in place of R, just write K. And what's the difference? If series, so series result will be valid for parallel, this parallel with the resistance, and this series will be for parallel combination for spring, parallel combination for spring. So in place of K, okay, in place of R, just replace R1 K1 and R2 K2 and delta of R, it will become delta of K. Again, this is a very important and famous trend this time. So this, if you take care of this, okay, definitely it will help you out a lot. Okay, so see, we have discussed, okay, mostly all the chapters. Okay, from here the questions coming, next questions coming from gravitation. If you see, so gravitation question is playing with you the orbital speed. So when question is playing with you the orbital speed, so you need to take care of the thing that orbital speed is basically what? Okay, root gm by r. Okay, so v orbital speed is what? One question asking you v orbital speed, this is what? Gm by r. So what is r here? This is r is the distance, this is r is orbit, okay, orbit radius of orbit. Okay, so take care of this thing. This is radius of orbit and this is the mass of the planet. So question will ask you the ratio v1 by v2. So basically what is for the same planet, if question is asking you, it comes like this: r2 divided by r1. So r is to r1 and r2 is what? Orbit. So if you take the square root of orbit, you will get the velocity of, okay, about the orbit. Okay, this is one concept you should take care in your brain. So question comes if from here, so definitely you can deal with this. Okay, So now if you come to the electrostatics, so what question is coming, you need to take care of the potential energy, okay, or from in gravitation as well. You need to take care of the potential energy. So potential energy was, suppose the any okay satellite is revolving in this orbit, and now you are changing the orbit, okay. So how much work you need to do? So do nothing, just change, calculate change in potential energy. What is change in potential energy? M by R1, and minus plus, it will come plus, and M by R2. You can take care of sign. So accordingly, this is amount of work done you need to do to shift the orbit of the satellite. Another concept is you need to take care of the what question will give you the electric field. Question, it will ask you the potential electric field. So always take care of this relation. Electric field is always with differentiation velocity potential with respect to x I cap. You can learn this like this: differentiation with respect to j cap, and differentiation of potential with respect to z and k cap, and you can find out electric field. So again, this is very important. So question is asking you electric field. Suppose question will give you the V equal to 2x square. This question is coming. So at point 1, 2, 3. So you need to find out potential at this point. Okay. So what you need to do? Just differentiate. Okay. Electric question asking you electric field at this point. Okay. So there is function of x. We need to differentiate with respect to x only. So dv by dx. So differentiate with respect to x. What is this? 4x. Okay. What is this electric field in direction of x? So take care of x. X is what here? 1. Question asking you the electric field at point 1. So what is coming? This 4 into 1 is 4. Okay, so you can take care of the unit. Okay, so electric field x point will be what? 4. If you take care of the unit, it will come what? Newton Coulomb minus 1. So potential, another thing you need to take care is the one thing is from capacitor. Okay, capacitor, combination of capacitor and all is very important. So one very important relation is when you insert any dielectrics inside the capacitor. So how the capacitor is changing, question play with the capacitor, ratio of the capacitor, and another thing is the power. Okay, power of cell. So power cell is very important. Okay, and if you're doing power, so also you should know the series combination of the cell, parallel combination of the cell, mixed combination of cell. Well, that is very important. You cannot avoid it. Next thing you should know current density. Okay, J equals to I by A. And you should know drift velocity I equals to NE. This relation is very important. What is drift velocity? E by M. E is electric field. A capital E is electric field. E is charge. E by M into tau. And you should know sigma. Sigma is what? Conductivity. That is what? Ne square tau by M. This is very important. Ne square tau by M. And what about resistivity? Opposite of conductivity, 1 by sigma. So that is what? M by Ne square tau. Again, this result is very important. So I'm just discussing last 3-4 concepts more. Okay, from here you should take care of this thing. So if you are inserting in a dielectrics, okay, suppose thickness T, this total thickness is 3, so I have some. So C will change like this: epsilon naught A by, so this is what? D minus T plus T by K. This result is very important. Without this you cannot think about anything. So C is epsilon naught A by D minus T plus T by K. So if suppose that this strip is suppose metal, okay, this is metal. So K becomes infinity. So for that, put K equals to infinity. So question can play with you here, and question will ask you the ratio of C1, C2 accordingly. So you no need to worry about it. If you know, you can solve it. Okay, no need to worry about it. This is one concept. Another concept is what question will ask you about the power. In power, okay, question can give you the some normal circuit. Okay, so basically just understand this. Suppose if I ask you the power, power is what? Okay, power is what? So this is there is cell over here, and this internal resistance is R, and this is capital R, and question is asking you the power in this. Okay, so what is power across suppose R? So what is I? I will be what? E divided by R plus R. This is one thing. This is EMF of this cell. So E by R plus R. So power is what? I square into R. Okay, I square into R. Because we are calculating power across load, so I am putting here capital R. Okay. So question asks about that maximum power. So when there is a condition for maximum power is R, it becomes equal to capital. This is very famous and very important. Is question asking this time from here. So you can't avoid this. Okay, so R equals to R. If you put R equals to R, you will get power maximum. So what is maximum power? Okay, E divided by, you put R, E and R. So this is what? E by 2 R whole square into R. If you solve it, it comes E square of 4R. So this is again very important relation. You cannot avoid it. Okay. This is one thing you will take care in your brain. Another thing I already said, current density, current, okay, conductivity, resistivity. So I'm leaving that. I'm coming to the semiconductor and modern physics. So in one semiconductor, I already, okay, I always say that, okay, gate is, concept of gate is very very important. Okay, in gate, okay, you should know about OR gate, you should know about AND gate, almost important. Okay, NOR gate, you should know about NAND gate. So NAND gate, and if you put, okay, suppose this is AND gate, okay, so this is what AND gate, okay, you are putting, okay, same input over here. Here you are putting same input here, and here you are putting complement, okay, so here you will get a complement. This is not, so this will give you not, okay. So if you are putting same input, you will get here not, okay. This is very very important. You should know about this relation. Another thing is that you should know about work function. You should know about the kinetic energy, maximum kinetic energy. Always should know the kinetic energy maximum value is what, EV naught, okay. Maximum kinetic energy is what, EV naught. And this maximum kinetic EV naught, suppose you are putting any energy, okay, so any energy, suppose hc by lambda. This lambda wavelength incident on any metal plate equals to what, work function phi naught, and plus from your kinetic energy maximum value will come. Question can give you directly this value in electron volt as this time giving. So EV, question will give you this EV in electron volt. This will also give you in electron volt. And the question will ask you the kinetic energy maximum. Then just do nothing. Okay, this electron volt. So I am just writing incident energy, incident photon energy in electron volt minus of, just subtract work function in electron volt. Okay, you will get kinetic energy maximum in electron volt. And if the question will ask you about the potential, so from here you can put out EV naught, you can get potential as well. This is one thing. And one last concept I am doing, okay, and then I have covered everything, is that, okay, if the question will ask you lambda. Lambda is what, h by mb. This is very very important relation. This time question coming from here, lambda is what, h by mb. So in place of mb you can write h by square root of 2mk. K is what, kinetic energy. And in case of kinetic energy, you can also write Q into delta V. So this is what, h by square root of 2m, and in place of K you can write Q into delta V potential. So here this time question is playing with the same, giving you the ratio of wavelength, lambda, maintaining the ratio of the lambda. Here giving you 1:1 ratio of wavelength, lambda by lambda. So you can play with the ratio, Q ratio question, can play with the m ratio, delta V ratio. So if you know this relation, you can solve any question. This is very very important relation this time coming. So I hope you understood the concept. And one question is coming that when photon is falling from third orbit to second orbit, second orbit to third orbit, so from there you should know this relation, that 1 by lambda equals to r into this is what, n1 by n1 square minus 1 by n2 square. This is again very very important. You should know that if you want to know this 1 by r, so 1 by r value is 90 nanometer. You can use it, but no need to use this relation. If question can give you also this value. So this is Rydberg constant, and that is 90 nanometer. If you take 1 by r, if you solve it to lambda. And so here basic understanding of n1 n2 is very very important. Ground, you are talking about ground state, means n1 is 1, okay, or question will directly mention you the n equals to 2, so third, second orbit to third orbit to second orbit. Your question is talking about first excited orbit, okay, orbit. So first excited orbit is, so n1 is what, then n is equals to 2. Second or excited orbit, so then n is equal to 3. Okay, question is talking about third excited orbit, then at that time n is equals to 4. So there again you can do mistakes. You should take care of all these things. If you take care of all these concepts, then okay, finally I can say the level of question was not too much tough and not too much easy. It was moderate. So if you had gone through so many questions, if you had done through the questions, if you know that the conceptual clarity is clear, okay, throughout the session, definitely you will solve all the questions. Till then, thank you.